Welcome to lesson 73. We're going to talk about regular polygons. So a regular polygon, we know by definition, is a polygon with any number of sides where the sides are all the same length. Any regular polygon can be inscribed in a circle. If the sides are all the same length, then that's the definition of the regular polygon. Well, if the sides are all the same length, then it creates this equidistant from the center situation, right? So it can go into a circle. If all the sides are the same, then all the angles are the same distance from the center of the polygon, which means you have a circle. These are radius at that point. From the center to the diagonal or to the corner, the angle, that's going to be a radius of the circle, right? And then from the radius point on the circle to the point where another radius touches, that's going to be a side, or what we call a chord in your circle. So this little triangle here, this is what we use to figure out the area of the regular polygon. We realize that because these are all the same sides, that we can create a diagonal from each angle to the center, and it's going to create a triangle. And the number of triangles that are going to be in your shape is going to be determined by the number of sides. And there's going to be that many equal triangles as the same number of sides in your regular polygon. So here we have a regular triangle. It has 3 sides. Well, it also has 3 equal triangles. The altitude of each of these triangles that are the same is going to be called the apothem. Okay, that's a little from here, from the center to the edge of the triangle, which is going to be the base of your regular polygon. It's from the center of your polygon to the base of the triangle that creates. This is called your apothem. All right, and this is what we're going to use to determine or to find the area of your regular polygon. We're going to take any regular polygon and we are going to divide it into regular triangles, find the area of that triangle, and then multiply it by the number of sides. So looking at each one of these, you can see sides that have, or regular polygons have the same number or an even number of sides, not the same number, but an even number. So 4 sides and 6 sides here, those are going to be really easy to find because you can just draw bisector diagonals and then it creates your triangle for you. With a uneven sided regular polygon, you have to kind of play around with it a little bit and see where you've got to measure, do a little bit of measuring and make sure that that is the center of your shape. So looking at, this is actually 73.1. We're going to look at a 5-sided or a pentagon, a regular pentagon. Pentagon. This is 73.1. And here's the clue. If we can put it inside of a circle, then the center of your regular polygon is at the center of the circle, right? We know a circle is 360 degrees. So however many triangles, which is however many sides the shape has, we're going to divide 360 degrees, and that is going to be that central, each one of those is going to be the central angle of your triangle, or the angle at the vertex in the center of your shape. So for instance, this is a 5-sided shape within a circle. So we say 360 divided by 5. Each one of these angles here is 72 degrees. Right? Absolutely. So now we take these triangles and we need to apply the apothem in order to find the degree of measure. So now that we've got this angle here as 72, we're going to draw a bisector that is vertical and perpendicular to the base of our triangle. And we're splitting that 72 into two angles. And we're creating a right triangle. Here's our 90 degree, here's our right triangle. With one angle is 36 degrees. So if this is 90, this is 36, this one has to be 54. And what we're going to do is we're going to label the base as X and the height of the triangle. This is your apothem. So your apothem is your height. So we're going to use sine and cosine to find X and A. And we were told that this has a radius of 6. That's what this circle has. So with a radius of 6, we know that these sides are 6 also. So I found, by using, for X, I found 6 times the sine of 36 is equal to 3.53. So X is equal to 3.53. And then I found the cosine of 36, which is going to give me the adjacent. Remember, the sine gives you the opposite, and cosine gives you the adjacent. The adjacent, or the cosine, gives you the apothem. So that was 4.85. So now all I need to do is find the area of the triangle and multiply it times 5 triangles to give me the area of the pentagon. So what I did was I said 3.53 times 4.85. Wait a minute, Miss Tracy. Area of a triangle is divided by 2. Yes, it is. However, remember, this is 4.85 and this little x is 3.53. This is already divided in half. We found the area of the whole thing because we divided the base by 2 when we found the apothem. So this has already been divided by 2, right? This 3.53 is already divided by 2. The area of this triangle would be 3.53 plus 3.53, or times 2, times the height, which is 4.85. So in just finding x, it's already divided by 2 because we only found one side. We found half of the base, right? So we've already got that division by 2 going on. So we can just say this half of the base times the height times 5 gives us the area of this regular pentagon, which would be 85.60 units, whatever those units of measure are, whether they're centimeters or meters or inches or feet or yards or whatever it is. So that's how we would do that. So let's do one more practice problem. And that's all we have for this lesson. So let me put it on the board for us. All right, 73.2. So here we have a regular polygon, and it tells us that the perimeter is equal to 48, and it is an 8-sided polygon. So an 8-sided polygon, I'm just going to go ahead and put it out there, it's octagon. An octagon is equal to 8 sides. So that tells me that the base of the polygon, 48 divided by 8, that's going to be 6. So the base of each one of these is 6. All right. So this is 6. So if we draw our apothem right here, and we know the base is 6, then that tells me this is 3 and this is 3. So you see what I mean by the base has already been divided by 2. So we can skip that step. So our apothum here is the height of this right triangle. All right, so what we need to do is figure out the degree of measure for the central angle here. We need to find this degree of measure. So we know that a circle is 360 degrees, and we know that there are 1, 2, 3, 4, 5, 6, 7, 8 sectors or 8 triangles within this circle. So let's find that degree of measure. So 360 divided by 8 is going to be 45 degrees. So each one of these is 45 degrees. So that means this one is 45 degrees as well, but we only want half of it. So we're going to divide that by 2, and that's going to be 22.5 degrees. All right, so that's our degree of measure here, 22.5 degrees. So we have 22.5, and we have an opposite length here of 3. So we're going to use tangent in order to find the apothum. All right, because we have, remember your SOHCAHTOA, we're always referring back to that and what that means. So TOA is opposite over adjacent. So that's how we can find A. So A is equal to the 3 over the tan of 22.5 degrees. So that is what we're going to do. And here, let me show you how we got that. You should know how we got it, but I'm going to do it anyway. So the tan of 22.5 degrees is equal to opposite, which is 3, over adjacent. We multiply everything by A, and we get A times the tan of 22.5 degrees is equal to 3. So then we divide by the known value. So A is equal to 3 divided by the tan of 22.5 degrees. So you can see how we got from point A to point B, right? Okay, so now we just do the math for that. I'm going to scooch this over a little bit. Let's pull up the calculator. So 3 divided by 22.5 tan equals 7.24. So A is equal to 7.24. So now we have the height and we have half of the base. So we can just say 8 times, because that's a triangle, of 3, which we've already gotten half. That's the 6 divided by 2. So we've already gotten our half, times 7.24. And when we do that, we get 3 times 7.24 times 8 is 173.76, whatever units. That is the degree of measure for the entire octagon. So it's not super hard. You just have to kind of be a little creative and imaginative and understand. The hardest part to me is always remembering that the base is already divided in half, because I have that automatic, base times height divided by 2. But remembering that the base is already divided by 2 because we split it in half to find the that information that we were looking for, the apothum here. so we could use our trigonometric function or formula, then, that's the part that I have to remember. It's already divided by 2, so I can skip that step. That's the part that's out of the ordinary, and I have to think about before I do it. But that is how you would find that. So we found the length of the base because we were told the perimeter. We knew the number of sides. We knew it's a regular octagon. So we just divided the perimeter by the number of sides and got 6 for each base, right? So then we divided that in 3 when we found our apothegm. So 3 and 3 is 6. So that's already divided by 2. We also use the number of sides to determine the number of triangles would be in our octagon. So we would divide 360 by 8 to find the central angle for each one of the triangles here, which allowed us to then find half of that for the right triangle that we created, so we could use SOHCAHTOA to find whatever missing information we had. And then that allowed us to find the apothegm, or the height of the triangle, and then multiply by the base that we had already divided by 2, then by 8, which was the number of triangles in the octagon, to get the number of units. So easy peasy, not a problem. That's all we have. That's it. That's honestly all we have for 73. So I will see you in 74.